This conference will now be recorded.
Hello, everybody. Jordan Girth here from the National Weather Service Office of Observations. Thank you for joining us for the Satellite Book Club Seminar Series. This is session number 67. The title of today's presentation, given by Bill Line, physical scientist at the Regional and Mesoscale Meteorology Branch of NESDIS STAR in Fort Collins, Colorado, is Satellite Imagery Applications During Burn Scar Flash Flood Events. Joined by my longtime colleague, Tim Schmidt, who's going to be facilitating today, meteorologist with the Advanced Satellite Products Branch, NESDIS STAR in Madison, Wisconsin. Just a few reminders before we get started that the session is being recorded. There'll be an opportunity for Q&A after the presentation. Please post your questions in the chat room and we will field them through there. We are particularly looking for comments and questions from our field offices and regional headquarters, so don't feel shy about getting your question in. We're also looking for future presenters, again, from our field offices. If you have an application you'd like to share with your colleagues in the field, please get in touch with us. We'd love to have you participate in a future Satellite Book Club seminar. And if you're looking for training materials, Brian Mata in the Office of the Chief Learning Officer can point you to materials or perhaps help create materials that may be unavailable. Thanks to our Tower S team, particularly Kashad Bowman, Lee Byerly out there, Office of the Chief Learning Officer, and the GOZAR and JPSS program for their support of the Satellite Book Club. This goes off without a hitch every week because of their support. Without further ado, I'd like to introduce Bill. Bill Line, as I mentioned, is a physical scientist with NESDIS STAR RAM-B in Fort Collins, Colorado. Bill conducts research into the detection of various mesoscale phenomena using NOAA satellite data. Also a previous Weather Service forecaster. Bill received both of his degrees from the great UW-Madison. Bill, welcome back to the Satellite Book Club.
Thank you so much, Jordan, for that great introduction. Go Badgers. And thank you to Tower S for inviting me to come back. It's great to be back. And thank you to all of you for joining today. This is definitely a relevant topic with several very active wildfire seasons over the past few years. There are many burn scars out there, and we're already seeing the devastating impacts of burn scar flash flooding. I also want to thank the many people who contributed to this presentation, especially Clint Skelly, Paul Schlatter, and Michael Charnick. So with this presentation, I'm going to start out discussing a quick background on what burn scars are, then a little bit about burn scar mapping, and then most of the talk around using satellite imagery during burn scar flash flood situations. So to start off real basically, and thank you, Tony Anderson, for some of this information. Wildfires completely changed the landscape, and most notably for us is that there are obvious changes to the hydrology of the landscape, and this is especially concerning when you have these burn scars across high mountainous terrain. Most basically, you're burning off all the leaves and green material within the tree, but also at the surface, so that when you have rainfall on a burn scar, it's going straight to the surface and not getting trapped in the canopy or in the ground cover. For moderate to more high intensity burns, you're actually altering the soil chemistry so that that moisture can't seep into the surface and it just runs right off of the surface. And finally, for the extreme burns, you'll actually age the soil up to 1,000 years within a matter of hours, again, allowing water to not seep into the soil, but running right off. Of course, this is an extreme threat to life and property. Most basically, you have your flash flooding, which is mostly a liquid phenomenon. Above that, a little more hazardous is your hyperconcentrated flows. So more of a gooey liquid, I like to call it, more of a dense, more destructive liquid. And finally, I think we're also familiar with your debris flows, which is extremely hazardous. You're carrying rocks, trees, etc., off of those burn scars. Of course, the impacts can be deadly and considerable. Just a couple recent events from the Grizzly Creek burn scar in central Colorado. There were days and days where flash flooding and debris flow caused I-70 to close. That's a major a highway through west to east across Colorado. There was actually one evening where motors were stranded in a tunnel overnight. I can't imagine what that would be like. And then also the train across Colorado had been canceled for a few days as well. And with the Cameron Peak burn scar also in Colorado, there's been some mudslides and flash flooding on that as well. And actually several folks killed with flash flooding off of the Cameron Peak burn scar this summer. So first things first, I want to talk about burn scar mapping, because obviously for providing DSS and issuing flash flood watches and warnings, we need to know where the burn scar is, and we want those maps in AWIPS and available to us to know how severe the burn is across portions of the burn scar. So while a fire is still burning, I think some of our initial maps will come from our IR mapping. So this is mapping where the fire is currently burning, but we can get an idea of the aerial extent of the burn from that. But again, that's capturing fire progression, and those flights aren't always available. Even better is our burn area reflectance classification, or BARC maps. These are derived from the very high resolution, several meter resolution Sentinel-2 and Landsat imagery, which are comparing pre and post fire vegetation, which gives us an idea of where the burn is, but also how severe the burn is. But these flights over a given location may be weeks before we get a clear view, because you have to deal with cloud cover, but also the swath widths are quite small. The ultimate map that we're going to use in our burn scar flash flood operations is from our Bear team assessments. So these assessments are done maybe sometimes before the fire is contained, but especially after the fire is contained. There's hydrologists, soil experts, engineers. They go on the fire and study the fire, the fire burn scar, study the landscape. And most relevant to us here today is they determine burn severity across the burn scar. They'll actually adjust the BARC map based on what they find in the field to create the final Bear maps. And that's the map on the right of the Cameron Peak burn scar, is the soil burn severity map, which gives you an idea of across the burn scar how severe is the burn. But if you look at the stats on the bottom, the first Bear soil burn severity map was available September 25th. Well, that fire was already over 100,000 acres on September 8th. So can we get better maps that give you an idea of the soil burn severity in the meantime as the fire is growing before we get those detailed maps? Can we leverage GOES and BEERS imagery to do this? And we actually can. I think at this point, maybe underutilized, but on the left are just a basic veggie band map I created and NDVI map on the bottom left there. Then on the right, we have while the Cameron Peak fire was still burning, it was a little break though. This is September 1st, so recall before that first Bear map was available. You can see the darker pixels where you have less reflectance, and the veggie band is where we burned, and you can see the lighter area in the NDVI. And if we overlay that final outline from the Bear map, you can see that the veggie band from BEERS actually did a pretty good idea of creating, and this is just a crude example, but showing you where that fire has burned, again, before those BARC and Bear maps became available. And there's actually a project from SIMS, this is from Sam Betzley, that it's called the Bridge Project, Burn Intensity Delta Greenness Estimation, that I think is being a little more intelligent and giving you more information. So looking at these top images, these are from Landsat, giving you on the left burn land cover from Landsat, and on the right an erosion product. Compare that for similar products from BEERS, coarser resolution, but you get the idea where you have your more severe burns and erosion predictions. So these are products from BEERS that we could get, I think, in a more timely manner than Landsat. So there's work to be done, and hopefully in the future you could request these types of maps while your fire is still burning, so that you could have that burn scar information before your Bear assessments are done. And then even more timely, up to the day and minute maps, but of course less spatial resolution, are from your GOES ABI imagery. This is just from yesterday, looking at some of the northern Colorado burn scars. You can see the Cameron Peak burn scar, East Troublesome Fire, quite well in just your basic veggie band imagery, and probably could do more intelligent things to get your very initial burn scar maps and compare those with the final bare outlines, and you could see how well they match up. Just shift it a little to the northwest because your GOES imagery is not terrain corrected, and these scars are in the high terrain. So these maps, you know, from those bare assessments, we get them, create shapefiles, and put them into AWIPs so that we can overlay them on our radar imagery, satellite imagery, etc. And again, also from those assessments, we're creating or establishing, typically from our service hydrologists, if you're lucky to have one, your rainfall thresholds for issuing a flash flood warning. So a new fire might have a threshold of just a ½ inch per hour rain rate for 1 to 2 radar scans. That might be enough to trigger flooding and for you to issue a flash flood warning. And also you would have a total rainfall threshold as well. And of course, those thresholds are adjusted as the burn scar recovers and as you have events on the burn scar to learn what does it actually take to cause flash flooding and debris flow. Also, we're relying on reports and observations from the burn scar. Maybe you have some rain gauges, but also people on the scene to provide firsthand knowledge of what's occurring during a rain event. And I just want to make clear that it doesn't have to be a slight risk, moderate risk day to cause heavy raining on these events. All it takes is an otherwise just a weak storm or a weak shower that you would otherwise not really care about. Those can cause significant hazardous flash flooding and debris flow. So it really takes, you know, many eyes on these days of widespread but weak storms. So now moving on to the day of shower and thunderstorm development near burn scars. I alluded to some of this, but warning decisions from the forecasters are typical based on the environment. You have enough moisture and stability, etc. But also radar data is obviously going to be your #1 source for warning operations if it's available and of quality. Obviously, we're talking about the West here, and we all know our radar coverage spatially is poor, but also we have a lot of radar beam blockage. You can see that from this map just over Colorado. Many of our burn scars have very poor radar coverage, so you have to rely on what you can get from radar, but also rely a little more on your satellite and lightning data, as well as ground truth, including rain gauges, spotters, etc. So starting off maybe early in the day, and I'm just going to cover some of the, I think, most important items to focus on burn scar flash flood days from satellite, as identified by me from my experience as a forecaster, but also the other forecasters across Colorado that contributed. Many of these burn scar days are on very weak forcing, your summertime convection. Maybe we have some monsoon moisture, and you just have your showers and thunderstorms developing daily across the high terrain. You don't know exactly where they're going to develop, and they might not move much because you have very weak flow and probably very weak forcing. But if you could identify maybe where your enhanced stream of moisture is, such as in this case on the western side of the ridge, in your southeasterly, the southerly moist flow, you can see where you have better moisture creeping up as opposed to the drier air to the east. But also identify subtle short waves, like in this imagery. You can see the very weak cyclonic flow, but it's there, a very weak short wave moving north within the greater moisture into north central Colorado. And maybe that's going to help to spark a slightly more widespread convection in northern Colorado during your time of convective initiation. And in this case, it did a little more widespread. This is July 30th. We'll show a couple of cases, a couple of examples from this event. But being able to identify those moisture streams, subtle short waves, is definitely important, maybe in providing or developing your forecast and providing guidance to your partners early on in the day. From that, you might look at some of your dry PW products. GOES has your TPW, but I think even more valuable is your blended polar precipitable water products, such as the layer PW. I think this might be available upon request in AWIPS, but it's also available online. Probably if you just Google serial layer PW, I'm sure you'll get to the link, or you could ask for the link. But being able to see moisture within the layers, I think over the years we've had several great examples showing how to utilize this product to identify potential widespread heavy rain prolonged events, in that you're able to see where you have moisture at all layers of the atmosphere overlaying each other, and maybe over the course of a day or a couple of days riding over an area leading to prolonged heavy rain, especially in the vicinity of burn scars. And this is a point I really want to stress, is that I think it's extremely important that you always make that 1-minute meso request when you think there's the threat of a shower and thunderstorm near your burn scars. I mean, it doesn't need to be a high, a slight risk day. Don't wait for SPC to make the request. If you have a marginal risk or just general thunderstorm risk, if you think there's going to be any sort of rainfall around the burn scars, definitely make that request. The 1-minute imagery is always giving you the most recent view of your shower and convective activity around the burn scar, with your most recent image always being only about 1 to 2 minutes old versus up to 5 to 7 minutes old with your 5-minute imagery on the left there. So you're always essentially up to date on what's happening. Further, the smoothness of the 1-minute imagery versus the choppiness of the 5-minute imagery really does allow the forecaster to make a quicker and more confident analysis of the scene. Things like identifying subtle boundaries and boundary interactions, analyzing the character of the Q field. Where are your cumulus clouds becoming more agitated? And where are we starting to see glaciation and convective initiation, sometimes from underneath cirrus clouds? And then as you have mature convection, tracking those updrafts and their movement. All of this can be done, I think, much quicker and with more confidence than with the 5-minute imagery. So it bugs me whenever I hear people say that 1-minute imagery is too much, or I don't look at 1-minute imagery because it's too many images. I just don't understand it, and I completely disagree. Based on my experience, you're not analyzing every single image. You're analyzing the animation of the images, and this analysis is made easier when you have more frames to complete that time period. So with this case, the 1-minute imagery was leveraged for this flash flooding event over the Hayden burn scar. There's a lot of cloud debris from ongoing surrounding convection, but the 1-minute imagery, I think, was the first source that gave us confidence where we had convection developing upstream of the burn scar, so that we could provide that early alert to our partners that something was headed for the burn scar. And this was in an area of quite poor radar coverage due to beam blockage. But we shouldn't be leveraging just the single band imagery, and especially in these situations for getting that head start, we should definitely be analyzing the day cloud phase distinction RGB. It incorporates the half-kilometer BIS, so you're still getting that high detail, but you're also getting information about where you first start to see that glaciation and convective initiation. And this is important because, again, you could provide that early alert to your EMs and other partners. Maybe they have crews working recovery efforts on the burn scar. You start to see that glaciation, you're going to want to let them know that lightning's becoming more likely with the mixed phase developing within the cloud over the next maybe hour or so, but also they should prepare because you're starting to see that initiation, and the flash flood threat would also be increasing over the burn scars. And I'll just play this animation out. Shortly after that last animation ended, you started to see more widespread convective initiation around the scars and flash flooding, and you can see it happens really quick. And with this event in the end of July, we had flash flooding and debris flow on both the Cameron Peak and East Troublesome burn scars in northern Colorado. Another event, and this one comments from the forecast office on how the day cloud phase distinction RGB was utilized in decision making. Early July on the Grizzly Creek burn scar, the one right along I-70, the date cloud phase distinction RGB was utilized. You could observe thunderstorm development to the west of the burn scar and to the east of the burn scar, and forecasters noted enhanced Q development and towering Q and the beginnings of glaciation here just upstream from the burn scar. And actually, based on the environment, these satellite trends and storm motion, they issued a flash flood watch for the burn scar. And this is, again, stressing the point that you're getting that early alert to your partners that the show's getting started and you've got some time, but this is your early warning. And then for this event, you could see that area to continue to grow and glaciate and initiate, eventually moving the burn scar, and forecasters issuing a flash flood warning based primarily off of radar data. Then again, if you have radar, that's going to be your decision maker, along with ground truth, issuing that warning roughly an hour after the watch. So pretty good lead time to their partners. And then a half an hour later, there was reported debris flow along I-70. I think it's also valuable to utilize your IR imagery, but utilize your IR imagery intelligently as the sandwich product, your semi-transparent IR on your visible imagery, so that you're maintaining the high detail from your BIS, so that you could still track the cumulus cloud development and maybe cloud top features, but you're adding in the quantitative aspect of the IR imagery so that you can observe where you have your cloud top cooling trends as well as your coldest cloud tops, which then you might correlate those to certain rain rate thresholds. And then onto derived products. I think there's value in many of the derived products that are probably underutilized, and maybe some forecasters don't know how they should utilize a cloud top phase product. But I know Tim has done a lot of work with this, and Tim Schmidt. And one way to leverage some of those cloud products is as a simple underlay in AWIPS under your day cloud phase distinction product. You might underlay cloud top phase so that when you're sampling, you're probably pretty confident. And I think by now we all know that the yellows to reds are glaciated cloud tops, but with that cloud top phase underlay, you see that it's actually ice, giving you maybe more confidence in what you're seeing, whereas this cyan cloud down here is super cold. Other ideas might be to underlay things like cloud top height, cloud top temperature on your BIS IR sandwich. And the last product I want to talk about is GLM data, especially in these burn scar flash flooding situations, not only for getting an idea of where you have maturing convection or your strongest updrafts, but also, as I mentioned earlier, you might have crews on some of these burn scars working mitigation and recovery efforts. I think GLM flash extent data has its special value in seeing how far those flashes are extending from the updraft, so that you can alert, again, those folks that there's a lightning threat emerging in the area, and you're going to want to get crews off of the fire. And as I mentioned, the GLM data, I think the most value is getting that extent information, but I think some forecasters might still want to view it as point data. I know I always like viewing lightning data as point data, especially if you're overlaying it on items with colorful color tables like IR. And I believe that the GLM point data is available in all NWS offices now, or most. They just need to activate it. So I think you could reach out on how to do that. And last item, I just want to put a word out on parallax, especially in these situations where you're trying to identify where you have a shower moving over a relatively small area or a burn scar. You need to account for parallax, especially in the mountains, whether you're looking at east or west. In the western US, there's going to be a considerable degree of parallax. So for example, in Colorado, you're going to want to mentally shift those cloud top features for a typical thunderstorm height, roughly maybe 12 to 15 kilometers to the southeast. And there's actually a great web page. I think just Google probably SIMS parallax, and you could get this web page where you could see what the degree of parallax is at any given point. And then there's just an example, one of the examples I showed, especially for this East Troublesome event. The mature convective updraft cloud top was northwest of the East Troublesome fire, but the parallax would put it, directly over the burn scar. So that is all I wanted to cover. I hope you all got something out of that on the burn scar mapping. Hopefully we could get some more of that VIIRS development for mapping burn scars, but also a lot of great uses of satellite imagery and products in burn scar flash flood situations. That is all I have. I look forward to answering questions, and feel free to reach out to me at my email if you have additional questions. And also, if you've ever got a really cool use of satellite and you want to share it, we could put together a quick case study and throw it up on the Satellite Liaison blog. Thanks a lot, and I'll throw it over to Tim.
All right. Well, thank you, Bill. Thank you for a very great presentation, really putting the environmental into the use of satellite data. So everybody stay around for the discussion that will follow. We're especially looking for participation from the field forecast offices and the regional headquarters. There'll also be the feedback survey posted in the chat, so take a look at that. Before the discussion, just a reminder that next week on the 23rd at 12 Eastern Time, Dr. Michael Pavlonis from the Advanced Satellite Products Branch from NESDIS STAR will be discussing prob severe lightning cast. I know that'll be a good presentation. Please contact the Tower S team, Lee Byerly or Kashad Bowman, for questions about the Satellite Book Club or configuration of satellite products. More will follow from an email from the Tower S team. So we'll get into the questions now. Again, please put them into the chat, or you could verbally ask them if you need to do it that way. So first question was about which VIIRS band was used for the veggie band specifically.
That would be, yeah, I2, I think roughly 0.86 micrometer band. I think it's pretty similar wavelength to the GOES veggie band.
Okay, thanks. Sam Batsley pointed out to thank Marianne Miller for the modeling erosion potential. I think there was a discussion in the chat about how GLM was used, but I think that was asked before you covered it. So if that wasn't completely covered, please restate your question. But I think you covered about the GLM use.
I do want to highlight Paul Schlatter from Boulder. His comment was great that some of their storms that produced debris flow had less than 5 cloud strikes, and I think that just reiterates the fact that no, not all of these are your intense, huge thunderstorms. They could be relatively weak thunderstorms and showers that cause great impacts.
Yeah.
So thanks, Paul.
Yep. I put in the chat that direct link to the Go16 CONUS web app for parallax. There are other sectors and satellites as well there. There's also a discussion about the, again, GLM point data, that it's the centroid and not the actual location of the flash.
Yeah, thanks, Jason. And I think the point that utility of the point data comes from monitor rates and changes, I think is a great point on using the centroids.
Bill Schoberg asks, have you discussed the JPSS burn scar work with Sam Batsley?
And yeah, obviously, yeah, I included a slide in this presentation, and I know it seems like that work's kind of taken a while. I remember talking about the VIIRS mapping a couple of years ago, but hopefully that takes off, and having something for forecasters to be able to create on the fly. Today, I want a map of this burn scar would be very valuable.
I'll also point out in the chat, there was a link to an AGU conference paper that people can look at about the bridge map progress. Remind everyone the link has been posted in the chat for the survey feedback, so please fill that in when you can. Mike from Cheyenne, just a few comments, reinforcements on storm coverage and intensity. I don't know if that's a question or a comment.
Yeah, go ahead, Michael.
Hey, yeah, this is Mike. Can you hear me?
Yep.
Awesome. Fantastic presentation, Bill. Really enjoyed it. I just wanted to comment and reinforce on one or two of the points here from a field perspective here. That one event that you showed out for the Grizzly Creek burn scar area in Grand Junction, I was actually working on the desk that day, and you made some points earlier that are really valid and I think that are worth reinforcing, is that it definitely does not take a big, moderate, or even slight risk hydrology day to cause problems in these cases. And I think this is where the satellite data truly has its value to the field, because in those sort of lower risk days, you're not going to have those big heads up emails and all of that build up to it. You're going to have to be watching carefully on satellite and radar for these signals. And in just the example that you have on the screen here, you can see that towering cumulus developing kind of almost in a perfect vector of what the winds were that day towards the Grizzly Creek burn scar. So on this day, precipitable water values were only in the 0.7 to 0.8 range. So, you know, nothing too spectacular. Surface CAPE was only around 500 to 800 joules. So it certainly wasn't anything that would initially stand out to you as a huge flood day. However, by monitoring the trends, we were able to see in this case that storms along I-70 had probably used the available energy already to the east and to the west of that circled area. However, in that circled area, there was still untapped and I guess, convectively turned over instability. And, you know, without the satellite data, we would have not known that. We would have not been able to say, okay, well, maybe the threat is already over. Looks like the storms already came through most of I-70, and maybe we, you know, sort of turn our attention elsewhere for that day. But the satellite really allowed us to key in on that area, and sure enough, we ended up getting flash flooding there. So I just think that's a big point to make, is that these types of products, and especially monitoring that 1 minute imagery that you were talking about, that latency thing, 1 minute versus 5 minute imagery is huge for this kind of event. I mean, just think about it from a DSS perspective. If you are getting images every minute with like 1 to 2 minutes of latency versus 5 to 7 minutes of latency, imagine if you're driving down the interstate into that canyon, and what you can do with 5 more minutes of latency as far as getting the message out, shutting down the highway, getting travelers further down the highway, and perhaps getting them out of harm's way. So I think that's just another point to make, that, you know, there is still some resistance here and there about using that 1 minute data. But when you put it in a impacts perspective and what it can do for people on the ground, I think that might be another way to, you know, really do some final sales on it to anybody who's still kind of resisting using it. So that's all I kind of have to say. I just wanted to get those points out.
Thank you so much, Michael. Those are fantastic points. I totally agree.
Yeah, I can say historically, before the launch of ABI, there were some people that told me that there were, quote unquote, be no operational use of 1 minute data. So anyways, what product that outlined the burn scars in red, what was it called, and is it functional, available in AWIPS?
I think maybe you're talking about this. These are just shape files, again, derived from maybe the bear maps or bark maps or whatever information you have about the burn aerial extent at the time, you create a simple shapefile and put it in AWIPS as a map so that you could have it loaded with your other data sets.
Okay. There are questions, are there plans to provide terrain-corrected GOES products, i.e. fire detection and parallax corrections?
Yeah, we recently implemented about a year ago terrain correction for the Beers imagery, and I think that's received, very much appreciated. So for GOES products, I haven't heard of any plans. There's just been informal discussion, but I don't know of any plans. If someone else does, they could mention that. In terms of parallax for clouds, I know we've tested that in the hazardous weather test bed, and comments were mixed. There's problems with when you're correcting the clouds, you're potentially covering up other important details such as the updraft. Forecasters have been viewing imagery with parallax for decades, and I think we have a good handle on it, and people know how to deal with it, because you are introducing some negative aspects when you parallax correct. But the terrain correction for surface features, I think, would be worthwhile.
Yeah, I don't think there are any specific plans on the GO side, but as you mentioned, there has been some research work by Chris Schmidt and others. Anthony Anderson, would your satellite analysis differ between a day-driven by warm rain processes versus a more convective environment? We've seen burn scar flash flooding from both.
Yeah, Tony, I hear what you're saying, and I do have, I think, a slide right here. This was one of those cases. It does really change your thinking, because in this case, it was more convective over Colorado Springs and at night, causing flash flooding. So where we had no radar coverage basically over this burn scar down here, we figured the same rain rates. However, it did not cause flash flooding. And I think because it was more warm rain processes for so weaker rainfall. So you do have to mentally adjust. And it can be hard, especially at night when you don't have visible imagery, because maybe your warm rain processes are going to be weaker rainfall, but as you mentioned, you might get flash flooding from both. So I think, yeah, I didn't have any examples for warm rain processes causing it, but certainly something to look at as well. Thanks, Tony.
Yep. Tony also mentioned the shape files come from the National Interagency Fire Center, and there are efforts underway to streamline the process so that the Weather Service can obtain those shape files.
Yeah, thanks for that clarification.
And Clint Skelly, you have some comments?
Yeah, hey, can you hear me just fine?
Yep.
All right, thank you. Yeah, so I'm a forecaster here in Pueblo. We've been dealing with flash flooding for a while. The Junkins that's noted on the screen right now, the spring burn scar. And, I guess, stressing the points of, some of the things that Bill had said about using the 1 minute data being as important as possible, because, we're here in Pueblo, we're doing like a, this bridging between the watch and the warning, with an emphasis on using mesoanalysis and using all of the data to create scientifically driven DSS. And so stressing the point of using all of the things that you have, using your surface products, using the mesoanalyst page, using satellite data to better, inform our core partners. So, as an example, using that 1 minute satellite data in these, topographically challenged areas that we have here in Colorado, KPUX doesn't really sample it all that well. And so if we can see this fine, meso feature that's back building and recreating updrafts over, even the chalk cliffs, not even just burn scars, but the chalk cliffs area, which is a highly flash flooding area, and the burn scars, of course. But using all of that data together, we can create a really quick graphic that we can send out to our core partners on our social media outlets. And so really just the combination of all of it especially with the satellite data, it's helping us create this really enhanced IDSS that we can provide our core partners. And so yeah, thanks for this presentation, Bill. It's fantastic.
Thanks so much, Clint, for joining today and providing those comments. It's great to hear perspectives from folks in the field continuing to deal with these annoying but high impact threats in the burn scars.
So we got a question from Jordan. So in 1 minute or less, what is one of the greatest challenges forecasters face during burn skull flash flood events?
I would say, based on my experience, it's the unknown. Often these burn scars are in very remote areas. You don't have people, you don't have rain gauges, and even if you do have radar, you don't know if that rain rate's causing flash flooding. You issue a warning and you still don't know if it's causing flash flooding. So I definitely say it's the unknown. You have to do your best to work with what you can and really be intelligent about leveraging other tools such as satellite and lightning to make your decisions.
Okay, thanks. And speaking of the future, are there any potential improvements for helping with burn scars in the future?
Yeah, I was talking to this guy, Tim Schmidt, and he created this graphic for me. I think one, potential area of improvement, if you really want to get, if you have a fire burning and you're expecting showers and thunderstorms, maybe while that fire's still burning, and for whatever reason you don't have access to the Beers imagery, you always have GOES imagery and AWIPS. If you could get higher resolution than our current 1 kilometer, 0.86 micrometer veggie band, maybe update it to 0.5 kilometer, which I think is a priority 3 item for the GeoXO program. If it looks closer to something like this on the right, I think that could be useful to operations and more of a real-time crude map of where is our burned area.
All right. Well, thank you, Bill, and thank you for all the questions. And I'll just, I think we're about at time here. I'll hand it back over to Jordan.
All right, thank you, Tim and Bill. Outstanding presentation today. I also really appreciate the Q&A section. I felt like we captured some good feedback from our field offices. So thanks to our audience as well for being engaged in today's presentation. The Satellite Book Club continues every Thursday. As Tim has already pointed out, we'll be back next week, Thursday at 12 noon Eastern time for Mike Pavlonis is going to be talking about prob severe lightning cast. So stay tuned for that. In the meantime, feel free to contact the TowerS team if you have questions about the book club or anything related to the configuration of satellite products, including what you heard in today's presentation. I hope you're staying well and your September is going well. Come back next week. Take care.
Thanks, everyone.